Welcome to the solutions to the Regents Physics Electromagnetism problem set, problems numbers 1 and 10. Number 1, you are lost in the woods but have a compass with you. But unfortunately, the red paint marking the North Pole has worn off. You do have a flashlight with a battery and a length of wire. How could you identify the North Pole of your compass to help you find your way? Neat application question here. So let's take a look. Alright, so what you want to do here is you want to create a solenoid with the wire. Just pick up a stick off the ground and wind the wire around the stick so that you make a solenoid that looks like this. You need to leave enough wire on each end to connect one end of the wire to the negative terminal and the other end of the wire to the positive terminal of the battery. Of course, what you're creating here when you do that is an electromagnet. Use the appropriate right-hand rule to determine which end of your solenoid is the North Pole and which end is the South Pole. So if we use conventional current, so let's suppose this end is connected to the positive terminal of the battery, the bump on the battery, this end connected to the flat indented side on the battery, so the negative terminal. Conventional current would go from the positive around the solenoid and to the negative. With this hand rule, your fingers curl in the direction of the current flow around the solenoid, and your thumb points at the North Pole of the magnetism created by that solenoid. So in applying that, we end up with this type of magnetic field where this would be your North Pole and this would be your South Pole. Now take your compass and bring it near the South Pole of your solenoid, and whichever end of your compass needle points to the South Pole is the North Pole of your compass needle. So in the question it said that the red paint marking had worn off, but I'm showing it here with the red paint on it. And you can see the North Pole of this compass is pointed at the South Pole of the electromagnet. Now once you've established that, you know that this end of your compass needle is the North Pole of your compass. Take it away from the magnetism, or just disconnect it from the battery, and then let the compass settle in the Earth's magnetic field. You'll know which direction is north, south, east, and west. Hopefully you know where a highway is or some kind of landmark, and you can start walking in that direction. So that's how you could use a flashlight battery and a length of wire to help you identify which pole of your compass is the North Pole, to help you not get lost. All right, number 10. The diagram below shows the end view of the electromagnet with a current as shown. What is the direction of the magnetic field inside the loop of wire, and what is the direction of the magnetic field outside the loop of wire? Well, the first thing you have to do is apply the hand rule here for a current carrying solenoid, current carrying coil of wire. You curl your fingers in the direction of the current flow, which would be in this direction, and you're on your right hand, and your thumb will point at the North Pole created by the magnetism. So in this case, the North Pole would be back here behind the solenoid. The South Pole would be out here in front of the solenoid. The direction of the magnetic field inside the loop of wire, you'll remember that magnetic field is defined to be the direction the North Pole of a compass would point, which is from north to south outside a magnet, but south to north inside the magnet. So inside the loop of wire, inside the coil here, it would be going into the page. Outside, it would be going away from the north towards the south, which would be out of the page. If you need any clarification on that, make sure you ask tomorrow in class. And that'll do it for the solutions on problems 1 through 10. We've covered them all either by way of video here or have done them together in class. And if you don't have any questions, you can expect a homework quiz on problems 1 through 11 in class tomorrow.